Okay, so I'm going to make a video reviewing Graham Forbes' system of logic. I'm going to review the rule of arrow introduction. I'm going to assume that you know the rule for conditional elimination, conjunction introduction, and conjunction elimination as well. So in this sort of example, I'm assuming that you've already sort of reviewed the first three rules. So for the rule of arrow introduction, conditional introduction, it's important to sort of read the schematics and follow it like a blueprint. So here it says that given an assumption, right? So this has to be an assumption. If you've assumed P and then you've derived Q, right, you may then create the conditional P arrow Q. And of course, this will come from your assumption on J and the consequent, which is K. And the rule of arrow introduction or conditional introduction allows you to write P arrow Q. So here, the dependency number has this weird formula. The dependency numbers from the consequent, which is Q, the set A, is included in M's, or your current line's dependency numbers. That's correct. But this means, this here, the /J, means that J is not included in the dependency numbers. J is discharged. And so I'll have a video reviewing how to discharge assumptions and the other rules that discharge assumptions. But for now, let's apply the rule of arrow introduction. So I'm going to give our example. It's going to be a familiar one. It's going to be W arrow T arrow D, right? Therefore, W and T arrow D. Okay, we have one premise. First premise is W, arrow T arrow D. So that's our first premise. Okay, so we just said that to use arrow introduction, you have to have an assumption, and then you have to derive the consequent. So what happens is, if we look at our conclusion, we can see that it's an arrow. And to make an arrow, you have to apply the rule of arrow introduction. So to do that, like I just said, we have to have an assumption. And it's usually pretty safe to assume the antecedent, the left-hand side, right, of the conditional you're going to make, not of the conditional that you have. So here's the material that we have, right? The formula is our premise, and so we have that to work with. And we want to make this. So in order to make this, we apply the rule of arrow introduction. And we need an assumption to use the rule, just like the schematic says. Right? We need an assumption. So what we are going to assume is actually W and T. And this parenthetical note just tells us when we are going to discharge or remove this assumption. So here, when we use the rule of arrow introduction, we remove this assumption from the dependency numbers. So on the third line, we're going to start to break down this formula that we're given and work with it to derive D, so that we can put the antecedent with the consequent to form the larger conditional. So first, we'll derive W from the second line. So from 2 and elimination. And then I'm going to derive T from that as well, using the same rule from the same line. All right. And then on line 5, what we're going to do is use arrow elimination to derive d. You see here, this is a huge consequent. It's a complex formula, so this whole thing is the consequent. And so in order to work with this, we have to take it out first. So with w, with the antecedent, we can derive the consequent. So here I'm going to use 1 and 3 to derive t arrow d. So it's from 1, 3, and that's arrow elimination. And so their dependency numbers will depend on what 1 and 3 depend on, which is 1 and 2. So on line 6, since we also have the antecedent to this conditional, we can derive d. Right? And so I'm going to derive d using 4 and 5, again, arrow elimination. This is the large conditional. This is the antecedent to that conditional, which allows me to derive d. Likewise, the dependency number for 6 comes from 4 and 5, which is 1 and 2. We don't have to repeat 2, so it's just 1 and 2. So afterwards, on line 7, now that we have d, which is our consequent, which is our goal, we're going to create the big conditional, w and t, right, arrow d. So this is derived from 2 and 6. And we've applied the rule of arrow introduction, creating a conditional. So now the dependency numbers for line 7 will come from 2 and 6. So 2 is an assumption, right, which the schematic says that here 2, or the antecedent rather, does not belong in the dependency numbers. So we have to discharge 2. So normally we would calculate 2 and 6, which is 1 and 2, but because 2 is an assumption, right, and we're using a discharging rule, we have to keep 2 out of the dependency number. So here the dependency number should only be 1, which matches up with our note that says that we're going to discharge this assumption when we use the rule arrow introduction. So that sums up the 4 rules that we sort of need to, that's 3 rules that we need to solve this, this proof. So this is how you apply the rules. We'll be back with some more videos and review.